Good morning, everyone. Good morning. Hope all is well and everyone is all right. So let's see. Hope everybody had a great weekend. Let's see where we're getting started today. Okay. I think we got complex numbers. I think we're doing solving and complex numbers. Let me confirm with Math Lab. Yep, 14.5 and 14.7. Okay, we'll see if we can get to 14.7 or not. But 14.5 is where we're starting today, solving rational equations. So here, first one, a plus 8 over 5 minus a plus 6 over 7 equal to 0. And we want to solve this for a. First thing we should do is clear out our fractions. And we did this process before. We had fractions in our regular equations. So it's the same thought process. You find your LCD first. Which is 35, because of 5 and the 7. Then we're going to multiply each numerator by the LCD. So notice we multiplied a plus 8 by 35, a plus 6 by 35, and the 0 by 35. Any problems? All right, next up is to simplify. Remember, our goal is to clear out the fact that we have fractions. So we want to get rid of the 5 and the 7 that's in our denominator. So that 5 can divide into 35, and leave you with 7. That 7 can divide into 35 and leave you with 5. And of course, 35 times 0 is 0. So this is what we have. 7 times a plus 8 minus 5 times a plus 6 equal to 0. All right, any questions, any questions? All right, next step is to solve. So we will go ahead and distribute. Distributing 7 is 7a plus 56. Distributing negative 5, that's minus 5a minus 30. All right. Combine your like terms. So 7a minus 5a is 2a. 56 minus 30 is 26. Subtract 26 from both sides. And then we divide both sides by 2. A is equal to negative 13. All right, any questions before we do another one? So the last step doesn't affect us in this case, but we will use it in examples to come. You know, it says check for extraneous value. That only occurs when there's a variable in the denominator. So if you go back and look at this problem, we only have 5. Oh, we only had 5, and then we had 7 in our denominators. So there was not a variable in our denominator. So when we have one in the denominator, then we'll talk about what that means. But that is your last step when it comes to solving these rational equations. You want to check for extraneous values. Those would be values that we cannot use. Sometimes people do that first, sometimes do it last. As long as you do it at some point, you should be able to, you should be good to go. Any questions? All right, can we go to the next one? All right, so we have 1 over 4 minus 3 over 4y equal to 2 over y minus 9 over 8. So once again, we want to find the LCD, common denominator. That's the smallest term that each one of the denominators can divide into evenly. So we see we have a 4, we have a 4y, we have a y, and we have an 8. So as far as 4 and 8, the smallest number that both 4 and 8 can divide into would be 8. And then of course, all we have is y. So that's why our LCD would be 8y, because of the 4, 8, and the y that is involved in each one of our denominators. All right, so step 2 is to multiply each numerator by the LCD. So we multiply each numerator by 8y. All right, so step 3 is to go ahead and reduce. So each one of your denominators, if you actually have an LCD, each one of your denominators should be able to divide into that evenly and cancel out. So let me put all my slashes back. All right, so 4 divides into 8 and leaves you with 2. 4 divides you into 8 leaves you with 2. And did I not cancel that out? Also, this y cancels. And then this one just y cancels. And then here 8 cancels. So what's left is 2y times 1. Here 2 times 3. Here 8 times 2. And then here what's left is y times 9. So make sure we're okay with the cancellation before we go any further.
Mr. Tucker, why is it that you cancel that before you actually like multiply everything in the numerator?
You can actually multiply if you want. It just makes things easier, especially if you're doing stuff in your head versus with a calculator.
Yeah.
So if you like, let's say if there were larger numbers that you were working with, it's easier to deal with the smaller numbers first, then multiply, versus dealing with the larger numbers. Now you're trying to figure out what can divide into the larger numbers.
For sure. Okay.
Yep.
But there wouldn't be any issue by just,
Nope, not at all. So yeah.
Okay, thank you.
Mm-hmm. All right, is everybody okay with what we have? And going back to your question, I have a habit of doing it this way because everything I am doing is in my mind. So I'm always best served to use the smaller numbers and then go larger versus using larger and then try to break it back down. So
Yeah, I totally get that. I agree. I'd do the same thing. I just wasn't sure if there's some technical issue why you.
Got you. Nope, it's the exact same thing will occur.
Fantastic. Thank you, sir.
Not a problem. So once you simplify what you have, 2y times 1 is just 2y, 2 times 3 is 6, 8 times 2 is 16, and then 9 times y is 9y. Make sure you hold true to all of your minus signs and plus signs. See that, still have minus and minus in the places accordingly. Now you want to get all of your terms with y on one side, all of your terms without y to the other side. So remember, it doesn't matter which way you go, which term you decide to move first. I decided to go ahead and add 9y to both sides. And that'll give me 11y minus 6 equal to 16. Then add 6 to both sides. That'll give you 11y equal to 22. And dividing by 11, y is equal to 2. So make sure we're okay before we go to that last step. All right, so everybody good. So now that last step, we talk about checking for extraneous values. You should be asking yourself, what values can y not equal? In other words, what values will make the equation undefined? Because remember, when we talk about fractions, whenever you have 0 in your denominator, that's undefined. So just giving you different ways of looking at what it means for a value to not work for us, or when will I have 0 in the denominator? So all three of those things are the same thing. What can y not be equal to? What values will make our equation undefined? Or in other words, when will I have 0 in my denominator? That's just, like I said, just 3 different questions that are the exact same thought process, and it'll give you the exact same answer. So to find out, what you would do is set your denominator equal to 0 and then solve that. Give you a chance to write that down before I scroll up. All right, so setting each denominator equal to 0 wasn't much to solve for. We had 4y. Now remember, we talked the denominator we're talking about are the ones that have y involved. So that would only be this one and this one. The other ones, there's nothing to plug in, here. So there's nothing to do. We're just talking about the ones that have y involved, your variable involved. So here, 4y equal to 0, divide both sides by 4, we have y equal to 0. And then the other one was just y, so y is equal to 0. So both of them end up giving me the same thing. So all right, so this is the value that y cannot equal. So it wasn't a problem this time because our solution ended up being 2. But if our solution ended up being 0, then we would have a problem. And then we'll talk about what happens, when we get there and run across that scenario. But this is how you figure out what values you cannot use. You set your denominator equal to 0, solve for it. That's the value that your solution cannot be equal to. This time we did not have a conflict. Y equal to 0 was the value that cannot be used. Our solution was 2. So there is no conflict. So there is no conflict with our solution. Like I said, of course, we're going to have one in which it would be the case. And we'll talk about that when we get there. All right. Everybody good? Can I scroll up? All right. So for the next one, -1 over a plus 4 minus 8 equal to 9 over a plus 4. So I went ahead and decided to go ahead and remember I mentioned that you can check for your extraneous values first if you want. I went ahead and did that. Our only denominator was a plus 4. So I said equal to 0 and solved and got -4. So this means that our solution cannot be -4. If I were to plug -4 in for a, -4 plus 4 is 0. We cannot have 0 in our denominator. All right. Everybody okay so far? And this is just explaining why, because if I were to plug -4 in, I would get 0 in my denominator, but that's what I was saying earlier. So now let's go ahead and solve. LCD is a plus 4. A plus 4 is the only denominator that we have. So that's why that's our LCD. So we multiply each numerator by a plus 4. Any problems? So now in that first fraction and the last fraction, a plus 4 is going to cancel out for us. That leave me with 1 minus 8 times a plus 4. All I did was just rearrange the terms. It's the same thing. And then just 9 on the other side of the equal sign. All right, so distribute -8. That'll be 1 minus 8a plus -32 equal to 9. Combine your like terms. 1 and -32 is -31. So that's -8a minus 31 equal to 9. All right. Go ahead and add 31 to both sides. That'll give you -8a equal to 40. Divide by -8, and a is equal to -5. So we didn't get a conflict. I think the next one has a conflict. But anyway, we'll see. Any problems? Any problems? All right. Hold on 1 second. Done quadratic. Hold on. I thought I had one separate. Nope. I thought for sure I had one that was conflicted like that. Because that one didn't do it. Hold on 1 second. I want to find one that conflicts exactly. I mean, this was a scenario, but I thought for sure I had one that actually did it. So let me do this, unless I have it down here. That one does. That one does. There it goes right there. Okay. All right. So let's go down this one, then I'll come back up. Yeah. So here we have 2x over x minus 4 equal to 8 over x minus 4 plus 1. So I just want to show legit conflict. So once again, 2x over x minus 4 equal to 8 over x minus 4 plus 1. So once again, over here in the purple, set your denominator equal to 0 and solve it for x. And that's the value that you cannot use. X minus 4 equals 0, add 4 to both sides. X is equal to 4. X equal to 4 is a value that I cannot use. If I plug in 4 right here, 4 minus 4 is 0, gives me 0 in my denominator. And that's what I do not want to occur. All right. So x minus 4 is going to be my LCD. That's the only denominator that I have. So I multiply each term by the x minus 4. All right. So cancel out the x minus 4. And that'll leave us with 2x equal to 8 plus x minus 4. Because we had this x minus 4 times 1 over here. All right. So from there, we can combine the like terms. 8 minus 4 is 4. So that'll leave us with 2x equal to 4 plus x. Now subtract x from both sides. That'll give us x equal to 4. So now this is the conflict that I was referring to. Notice our solution is x equal to 4. 4 is our solution, but we already established that we cannot use 4. So since 4 is our solution, but we cannot use it, that means our answer is actually no solution. We cannot use this value. It's considered extraneous. Extraneous are values that you solve for, but you end up not being able to use. So your answer is actually no solution. All right. Any problem with that one before we go to another one? Scroll up, everybody good? All right, so let's go back to this problem. All right, so this time we have x minus 6, and x in our denominators. So you take the two different denominators that you see, which is x, left my eraser on, which is x and x minus 6. Don't have to repeat the other x. So our LCD is x times x minus 6. Down here, multiplying each term by the LCD. And canceling out what's in common. So notice in the first one, the x cancels. And the second one, x minus 6 cancels. And the third one is just the x that cancels. And that leaves us with this. 20 times x minus 6 minus 20x equal to 6 times x minus 6. All right, distribute the 20 and distribute the 6. That'll be 20x. Let me erase this out. 20x minus 120 minus 20x equals 6x minus 36. Now on this left side of the equation, see we have like terms of x, and that's 20 minus 20, or 20x minus 20x. So both of those cancel, leaving you with just 120 on the left side, with negative 120 on the left side. So it's negative 120 equals 6x minus 36. Add 36 to both sides. That gives us negative 84 equals 6x. Divide by 6. Our solution is negative 14. Any problems? Any problems? All right, is everybody good? Oh, and just here, the two values that we couldn't use, 0 and 6, go back to checking these, setting them both equal to 0. So that's where that came from. 0 and 6 were the only values we couldn't use, so they had nothing to do with our 14, so we're okay. All right. Everybody okay with the next one? So we have 1/2 y minus 18y to the negative first power equals 0. So that y to the negative first power, we talked about negative exponents, a couple sections ago, maybe it probably should be a whole chapter ago, I think. Anyway, when we're dealing with exponents. So we want to make that positive, drop it down to your denominator, so that'll be 1/2 y minus 18 over y equal to 0. All right. So LCD, we have two denominators, 2 and y. We got this 2 right here and then the y right here. And so that's going to be our denominator, our LCD. So multiply each term by 2y. Erase these slashes real quick. All right, so cancel out what's in common. So we know 2y times 0 is just 0. Y's cancel out there, and the 2's cancel out in the first one. That leaves you with just y and y. 2 times 18, and then 0 on the right. All right, so that gives you y squared minus 36. Now we can factor that. That's the difference of squares. Y plus 6, y minus 6. Set each part equal to 0 and solve. Any problem? All right. Everybody good with that one before we scroll up? No, we already did that one, so don't copy that one. Very good. All right. Let's see this. Okay, last one. All right. So here we have x plus 14 over x minus 2 equal to 7x over x minus 2 plus 1. Our only denominator is x minus 2. So that's going to be our LCD. All right, multiply each term by x minus 2. See that it cancels here and here. Also, checking your extraneous value, x minus 2, set it equal to 0. So x cannot be equal to 2. So that's the value we cannot use. Cannot use that value. So here we have x times x minus 2. Excuse me, that'll give us x squared minus 2x plus 14. 7x is still left from that. And then x minus 2, so combine your like terms. Let me erase this. You have 8x minus 2 on the right. All right, so we have x squared minus 2x plus 14 equal to 8x minus 2. And so since we have this square here, we have a quadratic equation, we can set one side equal to 0. So I'm going to minus 8x on both sides and add 2. I'm going to cancel out over here. That leaves me with x squared minus 10x plus 16 equals 0. So factoring that, x squared minus 10x plus 16 gives you x minus 8, x minus 2. Set each part equal to 0 and solve. Here's x equal to 8, x equal to 2. All right, so we see we have two solutions here, but remember x equal to 2 was not a legitimate solution for us. So that one will not work. It is extraneous. It's not a solution. So our only solution here is x equal to 8. So notice we're not writing no solution. Remember, the only time there's no solution, if there is no solution. We have two options here for a solution. One of them didn't work. The other one did. So x equal to 8 would be our solution. Questions? Any questions? So we have all right. Everybody good? Everybody straight? All right. So all right. So before I do, anybody have any questions or anything? We can actually wait until next class to do this 14.7. But before we close out, though, anybody have any questions or any problems? But trying to think, it's stuck. All right. That wasn't unmute. Okay. So let's see. So as far as what's left, we have one more section in this chapter left. 17.7. Or not 17.7, 14.7. And then we have two chapters left as far as new content is concerned, chapter 17 and chapter 18. And that'll be it as far as new material is concerned. And from that point forward, it'll just be about reviewing and you guys getting your test in. And remember, you got to score at least a 75 or better on each test. All right. And of course, do all of your homework as well. All right. Questions on anything before we close out?
Will you be available for testing this coming Friday?
Yeah, we can go ahead and do that again. Only thing I asked, just like before, is that if you're going to test, that you come, between 9 and 9:30-ish, that you don't come after that, because then, that runs into me trying to get to the next class. But yeah. And I know,
Great.
I'm just reminding, the class, just saying, reminder.
Sounds good. Thank you.
Yep, not a problem. Anything else? Anybody else before we get out of here? Yep, not a problem. All right. So if you guys are good, I'm good. Once again, like your classmate mentioned, if you want to get a test in and you can wait until Friday, then I'll make that available Friday. Remember, it's your 9 o'clock Friday link that I sent to you as far as office hours are concerned. Also, but if you cannot wait, if you don't want to wait till Friday, or you cannot make Friday, don't forget you can get with Mr. Davis on taking your test as well. Other than that, you guys have a good one. Be safe, and I'll see you next class.
Have a great day.
All right. Thanks. You do the same.
Take it easy. Have a good one.
Thanks. You do the same, sir.